Hi ladies, so I'm going to work through 21.14 and 21.15 now, just so you get an idea of how to do these types of questions, okay? So remember, the whole aim of this is that we're trying to create this equation here from these three equations here, okay? So you might have to invert one, you might have to multiply one by two, and when you do that you have to make sure that you take into account the changes in the delta H's here. So let's have a look at this first of all. So look at our reactants. Our CH4 is here, it's on our product side, so we're going to have to definitely invert that, and our Cl2 is present in a number of different places. You've got Cl2 on this side, you've got Cl2 on this side. So let's have a little look at our CCl4. So CCl4 is definitely on our product side, so that's okay. So we keep that there. So I'm just gonna write beside this what we're gonna have to do. So we're gonna have to invert. Okay, so keep the same. Okay, and finally, what's the HCl? That's going to keep the same as well. But look at this, there's four of these guys here, but there's only one of these guys here, and HCl doesn't appear anywhere else. So we're going to have to multiply that last one by 4. Okay, so multiply by 4, and if we multiply that equation by 4, it means we're going to have to multiply that delta H by 4 as well. Okay, so let's have a little look at this. So invert the first one, so CH4, move this up a little bit, hopefully you can see this. So CH4, I'm just going to leave out the state symbol just for speed here at the moment. CH2 goes to C, and that means we change the H of this, change the delta H of this, so it's plus 74.9, that's that one done. Then the next one we're going to keep the same, we don't have to change anything there, so we just have to add it on. C plus 2Cl2, arrow goes to CCl4, and we just keep that the same. Delta H is equal to minus 139, and the next one we're going to have to multiply by 4. So if we multiply this by 4, girls, we're going to have to so it's going to be 4 over 2, which means essentially 2. So 2 H2s plus 2 Cl2s, arrow 4 HCl's. Okay, so we're going to have to multiply that 92.3 by 4. Turn on my calculator. 92.3 by 4 is minus 369.2. Okay, now let's see if this adds up to what we want it to be. So our 2H2s can be cancelled off there. Our let me see, what else can be cancelled off? Our carbon on this side, our carbon on that side can be cancelled off. Right, so let's add this up and see if this works out. So it's going to be CH4 plus 4Cl2, arrow goes to CCl4 plus 4HCl, and so that means we just have to add up our answers here and we get our result, which is what we're looking for. So it's 74.9 plus this is going to be minus, so 74.9 minus 139 minus 369.2. So the answer I get there, girls, is minus 433.3. Okay, so there's the answer there for 21.14. Alright, let's have a look at 21.15. So 21.15, again, we're trying to create this equation from these three given equations. So let's look to see where our start materials and where our products is. So first of all, I can see that this start material here is on this side, so we're going to have to invert this one. So I'll just write that there beside it, so invert. Next one, our carbon dioxide. Now, so carbon dioxide is only present on this equation here, and it's on the right side, so it's perfect. So keep the same. Okay, so we're going to invert that one, we're going to keep that one the same. Now, what other bits are similar? So we have 2 H2O's here, up here, in the thing that we want, but we only have one here, so we're going to multiply this across by 2, which means we're going to have to multiply our delta H by 2 as well. Okay, so let's do that. Okay, so first one we're going to keep. So C plus O2 CO2, so we're keeping that the same, so delta H is equal to minus 394. Next one we're going to multiply by 2, so it's 2 H2s plus O2 plus 2 over 2 is obviously 1. 2 H2Os, so we have to multiply that delta H by 2. So it's going to be 286 multiplied by 2. That is equal to minus 572. And then for the last one, we're going to invert it. So it's CH3OH arrow goes to C plus 2 H2s plus a half O2. And obviously we have to change the sign. So it was negative, now it's going to be positive 250. Let's see if that adds up to what we want it to be. So we can cross off anything that's on both sides. So we can cross off, what can we cross off? 2 H2s we can get rid of. Okay. What else can we get rid of? 2 carbons we can get rid of. What else can we get rid of? I think that might be it. So let's add these up. So CH3OH plus, if you can see, we've got 2 O2s there. So we'll see that will change in a second. Because you've got no 2 here, no 2 here, arrow, and goes to CO2 plus 2 H2O plus a half O2. Now you can take that over on that side and it will create 1.5 O2s, so 1.5 O2s, which is what we're looking for. So now we just have to add up our delta H's to get our overall answer. So it's minus 394 minus 572 and plus 250. And your answer there is minus 716 kilojoules per mole. Okay, so that answer there. So hopefully that's clear, girls. Now the last question, I'm not going to do it for you because I think hopefully those 2 examples are enough. But your answer, girls, for 21.16 is going to be minus 278 kilojoules per mole. So hopefully, girls, you got the hang of those. And let me know if you haven't, because I'll do some more if you haven't.